So, the second part of today's lecture is the basis of the pavement design. What actually we want to know. In a flexible pavement, what we are interested in know what is the tensile strain and what is the compressive strain. Now, tensile strain means fatigue cracking, and compressive strain means rutting. Tensile strain is calculated at the bottom of the asphalt concrete. As we know that normally we have two layers, asphalt bearing course and asphalt base course. So the tensile strain is calculated at the bottom of asphaltic base course. In some pavement, we may not need asphaltic base course. They are, very local roads pavement. So we don't have those asphaltic base course. So then the bottom of asphalt bearing course is where you calculate the tensile strain. And if the compressive strain is calculated at the top of the subgrade, top of the compacted subgrade. You know that there is a grade subgrade and there is a compacted subgrade. So we calculate compressive strain, the rutting, and it is associated with rutting is at the top of the subgrade. Now, if the pavement is failed due to fatigue cracking, that it means you have to redesign or you have to think the tensile strain, you have to improve the thickness. Normally, we increase the thickness of the asphalt base. We keep asphalt bearing course as the 2-inch, but you play with this depth. And more the depth of asphalt, more the depth of the pavement, the less chances of the failure of the asphalt concrete pavement. Automatically, it means that you have designed a pavement for more than an anticipated load. So that's why we can't control rutting. And when we say, when I was talking about, say, 8-ton load and 12-ton load, I mean for 8-ton load, you have a lesser thickness. For 12-ton, you may have more thickness. And for maybe for 20-ton, you may need more thickness. And that's, I have told you that because of the inadequate design, or because this inadequate design is because we have anticipated lesser axle load. And the pavement has failed because of the higher axle load. So if you may have designed a pavement for higher axle load, it may not have rutting. Consequently, you can say, or alternatively, you can say the more the thicker the pavement, the less chances of it will be of the failure. But mind you, this pavement must have an asphalt concrete. If it does not have an asphalt concrete, it will fail. Now, what is the mechanistic empirical performance prediction of the pavement? We design a pavement as per the traffic load. The other parameters is the climate. And if you know the asphalt pavement, you must be wondering how that climatic factor is considered. It means when you select a particular grade of an asphalt, it means You are taking care of its potential in the different hot temperatures. For example, we use 60, 70 response. The people you have for colder climate, they may use 8500 as well. But if the countries have got a more hotter climate, average more hotter, then they may use 40, 50. So the grade of an asphalt is what accommodates the temperature in empirical method. Actually, there is a lot of debate nowadays what grade should be used. Obviously, in the later part, we will discuss this as well. Later part of this course. Then, how you cater for the water, how you cater for the drainage. Because water, from the raining season, the water will come on the pavement. And the more it will retain on the pavement, the more damage it will do. Again, if you design a thicker pavement, you will have less water damage. If you define a thinner pavement, it have more different. But it's again, defining a thicker will not be enough. We have to have, you have to design a drainage layer or an asphaltic, granular base layer in such a manner that it can allow the water to pass through. But you must be wondering, sir, if this is like this, what about if the pavement, the water will pass through the pavement, it will get stuck on the subgrade. So again, your subgrade must be adequate enough. That's why we have a compacted subgrade. And if the subgrade is not, even the subgrade may allow water to pass through it. And it's a natural subgrade. So you may not have the liberty. So that's why to have the subgrade of your likeness, but then you have to do other measures to make this resilience subgrade so that it can accommodate water, one by allowing it, or if it is not, then you provide some drains underneath drain as well that can collect the water. So it's a science. What you do by taking the load, the climate, obviously the hot climate is by selecting a better material, and the rain by selecting a drainage layer, you design a pavement. You come up with this thickness. On that thickness, you measure stress and strain. You measure strain at the bottom of the asphalt layer, and you measure strain at the top of the subgrade. From that subgrade, from that strain analysis, you get the damage factor. One, or that strain will, this tensile strain will give you a distress value of fatigue cracking, and the compressive strain will give you the rutting value. Both of these are distresses, and both of these are the load damage. They are damaging the pavement. You must be wondering, when we have started discussing distresses, we had three types of distresses: the fatigue cracking, the rutting cracking, and the thermal cracking. But at the same time, I've told you that thermal cracking is not a structural failure of the pavement. That's why when you analyze the strain, you are not realizing it for the thermal cracking, right? That's why you have distress, and that distress will become more as the time passes, right? More the number of passes of the load together with climate, the distress will start getting bigger. On the initial stage of the pavement line, the effect of those damages were less. And as the load accumulates and the other factors accumulate over the time, your distress becomes increasing, and at one time you will fail. You will say this, the failure has occurred. So if you look at calculating the stress strain, that's we call mechanistic. And calculating the behavior based on this time analysis chart, time distress chart, this has come what we called an empirical way, mathematical way. Also, mechanistic is also a mathematical way, but this chart may have other shape. And why this chart has this S shape, you can say reverse shape, is because of an experience. And it has been evaluated from some data, and that data from that they have found that each time this is the behavior of the curve, right? This S curve. Now, what are first time I've told you that when we people started constructing the pavement, they were doing their experience. I used my experience, he used, but then they thought they must have projects. One of the major project that revolutionized the pavement design was Ashto road test. Then uh, in 90s, uh, late 90s, 97, 98, we have what called a SHARP project, SHRP. This is called SHARP project, Strategic Highway Research Program. And on the basis of strategic highway project, they come up with some called mechanistic empirical pavement design, right? And actually, SHARP has changed everything. Because up till 1950s, from 1956 to 1997, they were using, say, penetration grade bitumen, 60, 70, 8500. But in US, they start realizing that, simply getting this pavement, this material is not going to enough to sustain the rutting and low temperature cracking, as well as the fatigue cracking. So they have invested a lot of money. It was, a lot of $1 million project. I cannot remember that figure right now, but that actually changed everything. The material, the pavement, and the design techniques, the loading they were taking, and other than that, there was a mechanistic empirical pavement design guide that's also developed to compensate what people found in their strategic highway research program, SHARP program. So SHARP actually was meant for pavement design. It helped developing the pavement design guide, but actually it also incorporated the materials part that was not very well covered in an H2 method while they have designed. Now, these were the 1950s in which tracks were made. We can and that they allowed different vehicles of different configuration, like you can see the pickup trucks. Then there was trucks. There were 2-axle trucks and 3-axle trucks. Uh, Tandem axle was there, but not the trident axle, 3 axles. And then this is the way they have constructed the rigid pavements. What they have done is they have created loop like this. Half of the loop is of flexible pavement, and the other was the rigid pavement. So they've constructed different loops on different soil strata. And that was done between at Ottawa. And they found that was the layout of the H2 rotor. They constructed in such a. Now, this you can see is just obviously this cater for the truck is moving on one point from here to here. Say it's a flexible pavement, then it will come around and it will use the rigid pavement. So they can, detect the damages. They caught the damages. Another, you see, this the flexible test engine, then rigid test engine, then they have, pre-stressed concrete bridges between them. What was the finding of H2 test? The concept of serviceability, how the thickness of the pavement affects the pavement performance, and as a result, they have got H2 1993 pavement design guide, and it is still being used even in 2024. It is used and accepted document for pavement design in many of the countries, including our countries as well. Actually, the road you are traveling nowadays, it is based on H2 1993 pavement design guide. What is the serviceability? As the name suggests, how much pavement is serviceable during the lifetime. Obviously, when the pavement is constructed, it has given the best performance. But as the time passes, the condition deteriorated, and we expect that pavement should fail as per our design. For example, we estimated traffic for 20 years. We say the pavement should fail after 20 years. So you can see the three curves here. One is over design. It means there within, even after going through design life, the pavement is still in a good condition. It has not failed. Or in other words, it has not reached at terminal serviceability. The second one, the black line or the blue line, you can see, it's what we called a correct design. The pavement had failed exactly at the time what you designed for. And the orange line, unfortunately, you can see had crossed its terminal serviceability much before its design life. Now, this line under design means the pavement was a premature failure. Actually, this line is very ordinary, ideal life. Normally, you have a pavement failure much before this line. So this orange line is always, you can say, under design. But if, if has passed 90% of the line, that's okay. The problem is when this line is about 50% prematurely filled, then there's a problem. We seldom design over design because economically it will not, it's not favorite.
पाकिस्तान में वो डिजाइन यूज करना चाहिए ये जब कॉन्ट्रैक्टर बेस पे आता है तो इंटीरियर ऐसा ये यूज करते हैं.
You see, there are two things in the life. We don't have to compromise quality on the assumption that someone is not going to do it. I have a responsibility to design a pavement as per the guidelines, as per rules. If someone does not construct it, then it's his or her problem. We cannot over design such that to accommodate each and every. How much you are going to accommodate? Nothing. So we have, as a design engineer, we must stick to the policy. At least there should not be a problem with our design. If someone there's something what you call the quality. If the pavement is not constructed as per quality, then this should be corrected at that point, not in the design phase. This is how this H2 design book look like. What people think are the problem with this H2 design? Actually, it's old now, one thing. Actually, to me, it is designed, still we have developed parameters, but the type of loading at that in 50s and even in 90s are now different from the type of loading nowadays. They are specific climate, US climate, Pakistan climate, the Asian climate is different. The subgrade materials they have used, though they have used each time the lower material of less than CBR5, but still it's limited. You may not have CBR5 material all the time. You may have a more better material, or we may have a less material. And then we have a short performance period. Even though you are allowed to design for 50 years as per H2 guidance, but people don't design for 50 years. Well, some people think it's okay to design for 20 years, in 15 years, but in Pakistan, we normally design for 10 years. Because it's the unpredictable traffic. Again, now it's not only the traffic. When there is a road failure, people say it's traffic, but actually it's not the traffic alone, it's the climatic changes that has occurred. When the 20 years ago, we have a very, very less rain. We don't have this type of rain all the time in Karachi, but the climate has changed. So that's why you cannot have a consistent climate over the years. And with the world changes and all those stories we heard about, and obviously there are some facts in that about the climatic change. So then it's it's very difficult to predict the traffic. So that's why it has a failure. Now, this is where you see the data limit. We have those collected data, the pavement thickness of for 2 million, it's very okay. But as we go beyond 2 million or 100 millions, we design what we have to design for 200 millions, more than 100 million traffic. So there the projection goes wrong. It's not going to take those excellent, because the problem with the national design is it's only cater 50 million access. This is the most you can design. If you exceed, and the type of loading we are having, normally, if you accumulate them, you get sometime in 8 years, or sometime 15, 9 years or 10 years, not beyond that. And the problem is the pavement design method must remember this thing. You can interpolate the values. If you cannot extrapolate your result, even with the help of these computers, people are designing using H2 method even for 200 million SLs. But H2 method, H2 roads were never tested beyond 50 millions. So extrapolation is a sin. So yes, if you have 45 million traffic at the end of 10 years, and at the end of 12 years, your cumulative traffic is more than 50 million, stop here. Stop at 10. Even if your 50 million at the end of, say, 12 years, to be on the safer side, make it for 10 years. But even with the computers, don't go for the failure. More than 50 million SLs. Pavements are not designed for 100 million. Yes, flexible pavement, but rigid million you can go for 100 millions, but not then again 100 millions. So there is a limit for designing a pavement. And there is a limit for load. If you cannot control the load, limit the design line of the. Then come up with the strategic highway research program. I'm sorry, I was saying 1997, it was 1987. They spent 150 millions uh, for asphalt. They have got 50 million expenditure. They have done concrete and construction, highway operation, long-term pavement performance. They have evaluated that. And they come up with this mechanical empirical pavement design guide. The problem is this, it is very much localized on the US condition again. Because you don't have a formal method, manual method of calculating. Now you can design the pavement, but you can only design those pavement based on the material properties that is available in US. Because they have incorporated most of the thing in this MEPDG, and if you want to use, you just have to open the software. You just have to geographically locate your position, and this mechanical empirical pavement design software will automatically take the input because they have the database available that, for instance, if I am designing, I want to design a road in Karachi. So when I say Karachi, it will cater for all the data related to Karachi. For instance, the temperature data. For instance, the soil data at that location. For instance, the asphaltic, actually asphalt is related that, and any other data except the traffic data. They will, in material property, they will automatically incorporate. But the problem is this MEPDG is not for Karachi. And unfortunately, we don't have too much data for ourselves so that we can have this design. So either we can make an assumptions that we go and we search the state in which is very much similar to Karachi. It has the same value, but again, this will be more of hazard. And if you happens to be a consulting engineer and you have experienced people, when you design a pavement, they are asked you the source. And there you cannot explain them the source. And you say, this is my assumption that some state in US, they have this data, so it's very similar to Karachi. No. You must have your reference data. That's why in Karachi, in Pakistan, people are not using this MEPDG guide. Or my knowledge about this is very limited. So for doing this, we have to use our own data. We have to collect or we have to this. So what is this ME guide? Just for a knowledge, it analyzes new and rehabilitated pavement. HME means hot mix asphalt pavement. It analyzes the traffic. Instead of ESL, they say load spectra. Between these two load, this traffic on this region is accommodating 2 axle load, 3 axle load buses. That region may not, if I'm talking, say, for instance, I'm designing a barrier town road. Obviously, it is not good have a load spectrum of, say, 18-wheeler axle. I mean, there may be, cases where people may transport, but they are not going. This is not an highway. So empirical, so they have that different load spectra in the collector road as compared to the main motorway road. Then the climate, obviously the climate, what is the temperature, what is the coldest temperature, what is the frost susceptibility, what is the humidity factor, all things are incorporated. And they have characterized the material. They have come up with the different material properties of and material, and they've come up with different methods to test them. Even in those methods are very limited, remotely available. Even if you want to get those data as per MPPDG, they are very remotely available in Pakistan. For instance, I can say NED has no such facility to measure the elasticity modulus or resonant modulus of an asphalt concrete. They don't have facility to provide uh, PAV value, that's pressure ranging vessels value, different properties of uh, bending beam. There are different tests they provide, different parameters. Even the NUST has the only facility, or UT Texila or some other units. 3 or 4 universities in Pakistan, they have this. Again, they are using for the students. They may have been collecting data, but it's not universal. It's not easily available in Pakistan. So you cannot have empirical design guide for Pakistan right now at the moment. Maybe someone have done. Then how the problem is HMA, that even if you design for 50 years, is not going to get past 50 years. Because asphalt has its own aging problem. Because asphalt is extracted from petroleum product, and the petroleum has volatile. Even though while extracted, we have extracted most of the volatile material, but still there are volatile material that make it flexible. Believe me, if there is 0% volatile material, there is 0% volatile material in asphalt, it will not be flexible. It will crack itself. What happens with the aging effect is that these volatile get evaporated with the passage of the time. And that makes asphalt vulnerable. That's why aging is very important. You have a very good pavement design, very good estimated traffic. But the life of HMA, if you not predicted the life of HMA, I'll just go one thing beyond that. You know what an SHRP project has done? SHRP says that the problem with an asphalt, quality of an asphalt, is that the material you are getting is a useless material for the factories. And refinery factories, for them, this asphalt is a useless material. They give you the residue, though they do something about grading. But their main business is not asphalt. The main business is the oil production. So even though this is an additional product, this is an additional profit. But as compared to the prices of petroleum, as compared to the asphalt or bitumen, it's very less. So they least care about the quality. So what happened, SHRP, SHARP project, they have created an exclusive factories for processing asphalt. So what they do, they collect all the residue material from oil refinery, they send to another industry. And that is making the quality asphalt. The asphalt, that quality is reliable. They are doing some processes, obviously. And that's why they have an improved asphalt as compared to Pakistan's. Because they are not taking that residue material. Again, obviously, they will be more costlier than the cost has increased, but at the same time, its reliability as a material has increased. So they have concreted, they have come up with something. They have done this linear elastic analysis and finite element analysis to design the pavement, and they have based on the damage accumulation and the reliability analysis and user-friendly software with the guide. All you need to do is you don't have to bother much once you know the GIS location of your pavement. Most of the thing will be done. Obviously, there are inputs, the traffic.
Sir, if you refine it further, like as you said that they refine it in the another factory, so it will be more costlier than the rigid pavement as well.
No, it's not like this. The difference between rigid pavement and the flexible pavement is around 7 to 10 times. And with all those doing, it will be more, maybe 2 times or 3 times costlier than the uh, the ordinary asphalt pavement. It will not be 7 times. No, they are in US. Those researchers recommended those factories. In the material is processed, they are being tested for some other properties, and then they are allowed, once they pass the QC test, then they are allowed to get out. Because for them, asphalt is no more a useless material. That is their product. And when there is a prime product, you care more. Like unlike the oil refineries, the prime product, again, it's not as. So they have more focus, and that's why the cost has also increased. And they are doing more different. They are not doing what we call uh, asphalt that the form they get from the in the what we call the neat form, in the control form. They are adding polymers to it. And they are making asphalt more resistible. And they are using uh, asphalt. Even, in US, you will not find 60, 70 asphalt. And they will say 52-17. Now, what is that 52-17? We call this performance graded asphalt. 52 means the maximum temperature this asphalt can have here without failure is 52 degrees centigrade. This is not -17, it is -17. So 52 -17 means if there is a low temperature, the temperature in that region is up to -17, this grade is okay. But for instance, I am living in an area where my temperature is 64 highest on the higher side and -22. So I'm not going to use 52 -17 now. I will use 64 and then some grade, not -22, just -24, just on the same side. So they have come with the performance graded swap. Instead of, knowing its uh, depth that changes with the temperature, we use this penetration rate. They've come up with performance graded better. And again, I'm sorry, the infrastructure has, with all those things, has improved to some extent, but it is still not, 100%. It has not cured the disease of rutting and fatigue. But more research has to be done. Even this polymer modified asphalt, they have some problem as well. With all those refined, up-to-date material, modified material, still they are not controlling rutting as they should be. Secondly, you must understand this way now. A pavement's designed for 15 years. If I come up with some method, I will only check its performance at the end of the design life. So if it is a 2000 guide, actually the 2000 guide actually did not appear in 2000 guide. Actually, it appeared, I think, in 2012. It is named as 2000 guide, but 2012 means 2012 they have come up. And now if they have designed with the pavement, for say 15 years, still their pavement has not completed their life cycle. They have not completed 15 years. People have to again come up and see what they have designed, will have they performed as they were expected. So still this, even with this design, there are a lot of things that need to be checked for. This is a statement. Pavement is not last forever. Pavement is going to design for fail in a predictable way. In a predictable way, the way I predicted. Now, if it is not the way I predicted, fail earlier, then there is a disaster. And I don't think the pavement is uh, will last after the design, especially for the traffic we have. The traffic as well as the. So, as I've said, there is an aging factor combined with this heat. There is a traffic load and the moisture all damage the pavement. So, what are the factors? The traffic, the soil and the pavement material, the environment, the construction and maintenance. That was the part we were referring to. I have designed it's a very good pavement, but it was not constructed as per my design. The pavement is. Now, when we talk about traffic, how number, how much volume of traffic, what is the load, the tire pressure, what is the speed? All are you, all are, all can have, the extreme value can have a detrimental effect, and it alone is sufficient to damage the pavement. And when it combines with other, it will fail a pavement much earlier. High temperature, high traffic with hot temperatures, they will cause a pavement more earlier together with this. So this is what the loading is all about. And this is the type of traffic. Multi-wheelers traffic. And what is rutting? You see, the pavement has settled along the wheel path. This is your axle, and that has created. Not only this has caused, but because this pavement is a flexible material, if this comes down, it has no way to go down, it will come from the other side. That's why riding becomes dangerous. And the last week, one girl has fallen. Actually, she was riding a motorcycle on Gulstani Johar Bridge, and they have got this type of distresses. She fall within that, and there was a driver truck who ran over and she died. And that was because of the wrecking. Because she could not, sort out how to ride on this road. Her wheel got stuck, and that's so the rutting can also cause accident. It's very difficult to ride. We design pavement for dynamic load. We don't design park cars. You must be wondering why in our country the bridges get filled after rain, and you see many bridges have caused. Why it is failed? They are not supposed to fail because the pavement, the flexible pavement or whatever, the bridges are designed for dynamic load. Means the load is not constant. And the problem with our road is we have so much congestion that we have to wait long on a pavement, especially on the bridge pavement, and there are heavy vehicles that are being, together that must have passed through. They are staying, and that's why it's creating the stationary load, and pavements are not designed for stationary load. That's why you have a failure. So, performance, the road should be designed and constructed to provide a quality acceptance for the both private cars and commercial vehicles, and must perform the functional and structural during the design life. Now this we have, discovered, so just let me skip that. Actually, for design of pavement, we are interested in the elasticity modulus, the Poisson ratio, horizontal to vertical, the thickness, tensile strain at the bituminous layer against the bottom, and then the subgrade. All of these are the typical strain that we measured. Fatigue cracking is because the asphalt surface is inadequate enough. That's why if it inadequate depth, obviously it will cause sweat cracking. Permanent deformation, as we know, you can measure measured at this depth on the top of the soil. So I think okay, let's discuss for a few minutes. Soil and pavement materials. We had another problem that with the design, the material quality of the soil that also uh, impacts. Actually, there is a separate temperature chapter on soil, so we'll discuss there as well. Then there are environmental factors, moisture, temperature, energy that causes the failure. Then there's things what we call construction and maintenance, how pavement were constructed and how they are maintained. And this is how they actually damage the pavement and the performance of the pavement if they're not properly constructed. So you can use nowadays the pavers, very common, but again, they are very common in most of the big metropolitan cities of current Pakistan. Still in the smaller city, they don't use pavers. Or, pavers we use on motorways and highways. But still there are people who collect their local notes. They don't use pavers. They are using that simple um, mixed design mixed design machines, road plants. So we can, when talk about the aspect of the design, that means frictional failure or the structure failure. Functional failure is related to the safety. For example, you cannot apply the brakes. You're allowed. You're not even want to, have an 80 miles per hour speed, but 70 miles per hour speed. But because of the friction of the road, it is not offering you the resistance that you have. That causes safety issue, that's failure. Then there is a riding quality, bumpy roads. But that's also the functional failure. Still, the pavement has not damaged. The pavement damaged because of the traffic and the environmental load as well. So the structural failure means the strength failure. Functional failure means the skid resistance and the bumpy road. That's as you can see from this. So we stop here, right? So we'll discuss this thing in the next class.